Welcome to NASA Edge, an inside and outside look at all things NASA. On today's segment, we're going to give you an update on the Magnestopheric Multiscale Mission with Senior Project Scientist Tom Moore at NASA Goddard Space Flight Center. Let's see what NASA scientists have learned about magnetic reconnection. So Tom, I understand that you've been getting some great data from the MMS spacecraft. What have you discovered about the magnetosphere?
Yeah, the mission's been working like clockwork since it was kicked off off the launch booster. We have been seeing we're getting into all the places that we'd hope to see and measuring all the things we'd hope to measure. The amount of science productivity flowing out of the team is just difficult to keep up with. One of the things we caught is electrons doing their dance in space, or doing the weird things they do that actually enable reconnection to occur. And this happens on the very tiniest scales, just a few kilometers distance. And normally those scales have been invisible to all previous missions, but with MMS we flew in there and we could see a signature in the electrons of trajectories that some people thought those particles were executing. And it shows you how the electrons go from being sort of immune to energy dissipation to becoming an electrical current like we think of it that can dissipate power, and they can be accelerated by the electric field, the magnetic field in that case, absorb energy and take energy out of the plasmas that are driving the reconnection. And that is the key. That process makes reconnection possible, and it probably also sort of limits and controls how fast reconnection can go.
Well, how often so far have you seen reconnection with the MMS?
Well, we see it all the time. I mean, almost every time we pass through the magnetopause separating the magnetosphere from the solar wind, we see, you might call it the features of reconnection. Sometimes the place where the X line is, where the fields are crossing, that can be fairly distant from us. And we're seeing an exhaust flow. It's kind of like a big pump in the sky when it gets going. It sucks material in and spews it out continuously. So we often see the jets of flow exhausted from reconnection that's going on. But the key, right, for this electron stuff I'm talking about is that you have to fly right through the X line, and it's very small, very localized, so you have to get lucky. So far we've hit it maybe a dozen or two times on the day side of the magnetosphere. We also see lots of other stuff. In addition to this core process of reconnection, we see what you might call dynamics, the solar wind taking a bite out of the magnetosphere, if you will, kind of stripping off a layer, wrapping it up into a rope, and flinging it off the magnetosphere. It's kind of like, we call those a flux transfer event. But it's basically taking a bite out of the magnetosphere, ripping it away and carrying it away downstream.
Has nothing to do with the flux capacitor.
As far as I know.
Okay.
I've been trying to connect those two.
Based on the MMS mission and what you've learned to date and what you hopefully will learn in the next couple of years, what are some other aspects of the magnetosphere that you'd like to maybe study now that you've kind of, you've caught reconnection, you've seen it, you've seen the data? What would be the next step?
Well, there's a couple of topics that bubble up all the time. They're particle acceleration and turbulence. And so, especially as MMS completes the tail side phase that it's entering now, it'll go back to the day side, but at twice the radius, twice the distance out. So it'll be well out in the solar wind. So we would like to study solar wind particle acceleration and turbulence. There's not much reconnection out there. Sometimes you'll get different pieces of the solar wind that are reconnecting with each other. The fields have gotten twisted or something and they're relaxing. So you get turbulent features and you get particle acceleration events going on, some of them traceable way back to the sun, but some occurring locally in space. And that's really the next thing we're headed for on the day side.